Imagine waking up tomorrow morning, and the internet is gone. No YouTube. No WhatsApp. No Instagram. At first, you blame your Wi-Fi. Then you realize, entire countries are disconnected. Airplanes begin facing communication problems. Banks stop processing transactions. Emergency services switch to backup systems. Was it hackers? Was it artificial intelligence? Was it a global war? No. The real culprit isn't on Earth at all. It's the sun. The same sun that gives us daylight, grows our food, and makes life on Earth possible. But hidden beneath its bright, peaceful appearance, the sun is an enormous sphere of superheated plasma powered by nuclear fusion. Deep inside its core, hydrogen atoms are squeezed together so intensely that they fuse into helium. Every second, this process releases an unimaginable amount of energy. But like every star in the universe, the sun isn't perfectly calm. Its surface constantly twists with powerful magnetic fields. Sometimes those magnetic fields suddenly snap and reconnect. When that happens, the sun releases an enormous burst of energy known as a solar flare. And sometimes, that flare is followed by something even more dangerous, a coronal mass ejection. Imagine billions of tons of electrically charged plasma being hurled into space. Most of these eruptions never reach Earth. But when one is aimed directly at our planet, the journey takes only 1 to 3 days. As the cloud of charged particles arrives, it collides with Earth's magnetic field. Fortunately, our planet has a natural shield called the magnetosphere. This invisible magnetic bubble protects us from most harmful particles coming from space. Usually, these solar particles simply create one of nature's most beautiful sights, the northern and southern lights. But when a solar storm is especially powerful, that same shield begins to shake. Those disturbances can generate powerful electrical currents across the planet. The danger isn't that sunlight burns the internet. The real danger is electricity. Long metal conductors, such as power transmission lines, can pick up these induced currents. Transformers can be damaged. Power grids can fail. And once electricity disappears, the internet begins to disappear with it. Many people believe the internet comes mainly from satellites. It doesn't. More than 95% of international internet traffic travels through thousands of kilometers of fiber optic cables lying on the ocean floor. These cables connect continents, carrying almost everything we do online. Every email. Every video call. Every online payment. Every social media post. Every cloud backup. The light traveling inside the fiber isn't easily affected by solar storms. But the systems that power and support these networks can be. If major power grids fail or critical communication equipment is damaged, large parts of the global internet could be disrupted. And that's when the real problems begin. Hospitals depend on digital communication. Banks rely on secure networks. Air traffic uses satellite navigation and communication systems. Shipping companies track cargo across oceans. Businesses depend on cloud computing. Governments rely on digital infrastructure every single day. Modern civilization isn't just connected to the internet. It depends on it. And this isn't just a theory. Something similar has already happened. In 1859, the Earth was struck by the most powerful solar storm ever recorded. Today, it's known as the Carrington event. At that time, there were no smartphones. No satellites. No computers. The world's most advanced communication system was the telegraph. Even that wasn't safe. Telegraph operators received electric shocks. Some equipment sparked and caught fire. Messages were interrupted around the world. Auroras appeared so brightly that people could read newspapers outdoors in the middle of the night. If a storm of that magnitude happened today, the consequences could be much greater. Not because the sun has become more dangerous, but because humanity has become far more dependent on technology. Scientists have even witnessed close calls in recent history. In 2012, an extremely powerful solar eruption crossed Earth's orbit. Fortunately, our planet had already moved past that point in space. If the timing had been different, the outcome might have been far more disruptive. That's why scientists constantly watch the sun. Spacecraft monitor its surface every day, searching for signs of powerful eruptions. When a major solar storm is detected, operators of satellites, power grids, and communication systems can receive warnings. Those warnings give engineers time to prepare. Satellites can switch into protective modes. Power companies can reduce stress on electrical grids. Critical systems can activate emergency procedures. These preparations greatly reduce the risk, but they cannot eliminate it entirely. The sun follows an approximately 11-year cycle. During periods of maximum activity, solar storms become more common. Most of them pass harmlessly. Some create nothing more than beautiful auroras. But every so often, the sun reminds us that even the most advanced civilization on Earth is still living beside a star we cannot control. The greatest threat to our digital world may not come from hackers. It may not come from artificial intelligence. It may not come from war. It could come from the same star that has kept life alive for billions of years. Every message you send, every video you stream, every online class, every digital payment exists because an invisible web of technology continues working every second. And that technology ultimately depends on something far beyond human control. The next time your internet slows down, take a moment to look up at the sky. Because the brightest object you see isn't just giving us light. It's also a reminder that our modern civilization is more fragile than we often realize. The sun gives us life, but under the right conditions. It also has the power to remind humanity just how connected, and how vulnerable, our world has become.